Assalamualaikum and a very good day to evaluation panel. My name is Aiman Nurzharfan bin Mohd Yusni and my Matrik number is A24CS039. My project supervisor is Associate Professor Dr. Anazida and I'm from Program 3 SECRH. So without further ado, we go to the next slide. So for my project problem background is first is the centralized control vulnerability, which is the SDN breed, which is relies on centralized controller that creates a single point of failure, which means if the brain fails to work, the entire network is down. That is a huge problem. And the second problem is the stealthy attack vectors, which is the low rate DDoS and the TCP SYN floods that exploits the controller weakness, which means if the brain is flooded with attacks, the entire network will be down, which we plan to solve that problem. And the third one is the baseline poisoning. This is how attackers bypass their attack these days, which is by slowly poison the network baseline. And next one is the controller overload, which is if these problems happen, the SDN will be overloaded and the CPU exhaustion bring entire network offline. Okay, so this is an example of how the attack will happen. So the attacker will send a lot of TCP into the server, and then the port will be open, which will be waiting for the ACK, which is the acknowledge packet, as you can see here. Attacker sends for, and then the server requests for, but the attacker doesn't reply with any ACK package and keeps sending more SYN package, which will make the legit visitor that plans to visit the web cannot be connected. Okay, so and my research objective is first is the parameter optimization, which is to make the attack detection accurate and minimize controller processing delay, which means if this research cannot completely eliminate this problem but can optimize it. And then the algorithmic design, which is my design, is to propose the TCP SYN detection model that analyzes the past traffic, which I will explain later, and handshake ratio to bypass it, which mitigates attack and minimal controller overhead. And the third one is the testing and evaluation, which we will be testing this research later using a real life data set, which will be simulated in an environment. So the proposed solution is two mechanisms, which is the first mechanism, which is the multi-window dynamic threshold. It analyzes the historical time frame with three windows, which is the short, medium, and the long windows, and then it detects sudden spike and creeping attacks. And after the first mechanism notice the attack, it will send to the second mechanism, which is the TCP SYN ACK ratio check, which monitor the handshake ratio, drops massive SYN flood with no ACK response, and lightweight detection built into controller, which is this solution isn't really heavy. We will implement it in the brain of the SDN controller. So let's see the mechanism one, which is the multi-window dynamic threshold. So the first window is the short window detects sudden spike in the entire time frame. You can see the window one is pretty short, so if it detects a sudden burst of TCP, it will alert the second mechanism. So another window is the building trends, which is this can detect the poisoning by attacker. Means if attacker keeps sending keep attacking SYN in a slow rate, which is for example they send 10 packets and then 11 packets and then 13 packets, this will look a bit suspicious and will alert the second mechanism. And the third one is the window 3, this one, which is the long window. This one will check the entire timeline, and it check from the first time we set um, how much the packet has it received. Like for example, when first it start, it received like 5 packets, and then at the end of the window, it suddenly turned into 20 packets, which means they have successfully poisoned the timeline. But the third window will detect it and send it to the second mechanism. So let's go to the second mechanism, which is the TCP SYN ACK ratio check. So this is the receive alert from the mechanism 1, which is the previous mechanism. So if they receive alert from any one of the window, this mechanism will check if the SYN and ACK ratio is 1 by 1. Because if the attacker send a SYN packet and keep spamming it, they will never receive the acknowledged ratio, which is how we prevent it. So if it is a yes, then we will forward the packet because it is a normal traffic, which means, for example, there is a sale in the website, means a lot of buyer will come to the website to check out the item. So this is like a normal sudden burst of packets. But if it is an attacker which spam the SYN packet without the acknowledged packet, which is the no. Yes, you can see here, high SYN but zero ACK. Then we will drop the packet and block the attacker, which is the massive SYN flood. And then the project scope and requirement, which is the requirement and what I will be using for this research. We will simulate the target attack, network and transport layer attack, including TCP SYN flood and the low rate DDoS attack, which is the baseline poisoning. And then the environment, where will we be testing this research is the simulated SDN using Mininet network emulator with Python-based Rio controller. And then for the tools and software, some of it is we will simulate it in the Ubuntu virtual machine, and the code will be using Python 3, and the attack will be using HPing3 and SKP, which will simulate the attack in the VM. Okay. And data collection, to simulate the real world attack, we will be using the CIC DDoS 2019 benchmark dataset, which can be found online, or you can see in my proposal. Okay, so and finally the conclusion and expected outcome of this research, which is the accurate attack identification. So it may be not perfect, but it can be pretty accurate, which detect and block creeping DDoS attacks with precision. And then the lightweight solution, which means this if this is successfully implemented, it is pretty lightweight and can be implemented in the SDN, which prevent false alarm during normal high traffic condition. Like I said before, during a sale, it can be false alarm, will block which will block customer from accessing the website during high period. And finally, is the controller protection, which prevents CPU exhaustion and maintains network uptime. Which means if this problem is solved, the CPU exhaustion problem can be solved because there is less CNI attack. And that is all from my proposal for the final project one. And a big thank you for all panel for staying until the end of video. Thank you very much.